In this series so far, I've had to spend a lot of time telling ChatGPT not to use arrays in the exercises it provides, but now finally we know about arrays, so we can actually ask it for some exercises on arrays, and it better have some, frankly, after all of this. I just learned about arrays, finally, in my C programming course. Can you give me 3 programming exercises involving arrays? Of course! Okay, so it says working with arrays is a fundamental, yes. Here are 3 programming exercises involving arrays. Okay, so it's give me the solution. So can you rewrite that without giving me the solution? You'd think it would have figured that out. Okay, here are 3 exercises without providing the complete solutions. Exercise 1, sum of array elements. Write a program that calculates the sum of all elements in an array of integers. Now we've done this definitely by now, so I'm going to actually ask it for a replacement of this one. Exercise 2, finding minimum and maximum. Okay, I'll do that one. Exercise 3, write a program that reverses the elements of an array in place. Okay, that's neat. So I think we've actually done this exercise already, but not the version where it reverses the elements of the array in place. I'm going to ask it for a replacement for exercise 1, though. Exercise 1 seems a bit too easy for my taste. Can you generate a replacement? Certainly, okay. So, exercise 1 updated. Array element occurrences. Write a program that takes an array of integers and a target integer as input. The program should count and display the number of occurrences of the target integer in the array. Okay, that looks like a good exercise. So I think what I'll do is I'm going to start with the one that it's labeled as exercise 2, because I think of all 3 that I'm going to go with, that probably is the most straightforward one. Write a program that finds the minimum and maximum values, or maximum and minimum values, in an array of integers. It's an incredibly short prompt. It's actually much shorter than most of the prompts ChatGPT has been giving me recently, but that's fine. There's plenty of room for interpretation, so we'll start with that. Write a program that finds the maximum and minimum. So I'm strangely bothered by minimum not coming before maximum here. It just feels like that's the wrong order. So I'm going to make an editorial change. Okay, so we have to have an array of integers. It doesn't explain that much about where I'm supposed to get the array from. So we'll start simple here. I'm going to create an array of my own using curly brackets to initialize the array. So let's make up an array with some values. Let's make sure that I use a sort of diverse range of values, and that I make sure not to put them in some order. So for example, if I make an array that's just this, I've got only positive numbers and they're in sorted ascending order, and that could have an impact on my result. So I'm going to use a mixture of positive and negative values, and I'm going to try and make sure that there's no natural ordering to them. So they sort of seem arbitrary. So I'll use 2023, and it's currently August 23rd, so I'll do -8, 2, 3. Okay, so I've got a combination of positive and negative values. I'm going to find the minimum and maximum, and so it's useful that I make sure that I test on cases where the minimum and maximum occur in various different places inside my array. So for the time being, my array looks like I've got a total of 8 elements. I'm going to put the 8 here, because that way if I change it later and I change it to 9 elements or something, the compiler will give me a warning about that. Okay, so, but we already know that if I just left those square brackets empty, it would create the array to be size 8. It would create the array to be whatever size the initializer on the right is. And so actually I'll also make a note to myself that a size equals 8, just to make it absolutely clear for later. Now the question is, how should I do this finding the minimum and maximum values? I could do this by writing functions. I could write one function to find the minimum, one function to find the maximum. I could use just one loop that does everything inside of main. I could even write a function that finds both the minimum and maximum at the same time, so in one fell swoop. But I think I'm going to start by just doing everything inside of main. All right, so I guess the way that I should do this is I should begin by saying that the minimum value and the maximum value are both equal to the first value inside of the array. Now, if there's a concern that the array might have nothing in it, so the array might have size 0, then I might have to adjust the procedure that I'm using here. But in this case, I'm going to start by assuming that my array will always have at least one element in it, because arguably, if your array has nothing in it, then what would the minimum be? What would the maximum be? How are you going to define those terms? Okay, so I'm going to begin by saying that the minimum of the array is a sub 0, so the first element, and so is the maximum. And my goal here is basically to figure out, so if I've got my array, there it is, what I'm going to do is adopt a convention where I'm going to walk along from left to right, and as I go along, I'm going to learn more about the elements in the array. So currently, I only know about one thing. So as of lines 17 and 18, what I'm basically working with is this idea that currently I know nothing about the rest of the array. I've just looked at the very first value. And if I've only looked at one value in my array, then that's by default going to be the minimum thing I've seen so far and the maximum thing that I've seen so far. And then I'm going to walk through all the remaining values, and as they get exposed, as I see them, as I loop over them, then I will adjust my minimum and maximum accordingly. Okay, so that's my idea. I'm going to need a loop that iterates over the array. I guess I could have my loop start at index number 1. There's no reason that I need to work with index 0 any further because I already have accounted for it here. Although I don't have to do that. It would actually work just fine if my loop started at index 0 because maybe I'm so used to writing that loop that it would be more convenient for me. So one way or another, I actually couldn't go wrong either way, but I'm going to start at index 1. So I'm going to use a for loop for this. I'm going to use I as my counter for I starts at 1. I is less than a size. I++. And one of the reasons I made my variable a size is so that if I want to test on arrays of different sizes, it'll be easy to do so. I just modify these two lines. I don't worry about my program, about breaking something elsewhere in my program if the size of my array changes. All right, so at each step, I'm looking at one element of the array, so I'm going to think about a sub I. And I guess I'm going to ask the question first, is a sub I less than the minimum that I've already seen? So among the elements I've already seen, this variable minimum contains the smallest. If a sub I is smaller than that, well then I guess a sub I is now, I guess the minimum is now going to be a sub I. And then I'll do something pretty similar for the maximum. So if a sub I is greater than the maximum value that I've seen so far, well, in that case, I guess the maximum value will become a sub I. And we're not being expected, apparently, to remember where I found the minimum and maximum, just what they are. There are versions of this exercise, this being a pretty classic array exercise, there are versions of this exercise that might ask instead, tell me what index the minimum element occurs, or what index the maximum element occurs, or tell me whether the minimum or maximum elements occur in more than one place. So in the array that I've created, there's only one maximum element. It's this element here, 2023. But it's valid for that element to appear more than once. So, I mean, I could have a situation like this where the same maximum value occurs twice. And I should make sure I test that when it comes to that point. But I'm going to stick with the array I created for now. Okay, and so I guess I'll just print out what I have. The minimum is, and the maximum is. All right, I'll print out minimum and maximum. There we go. And then we'll try running this. So it did compile, that's a good sign. The minimum is -8 and the maximum is 2023, and that checks out. So in the array that I created of size 8, that seems to check out. Now I have to test, and with arrays being brought into the mix, the need to test thoroughly becomes even more important because there are a lot more ways something can go wrong. Not just because there's more data, obviously our arrays allow us to work with more data, but because there are more special cases. Generally, when you're working with algorithms that deal with arrays, you want to make sure you test carefully situations where some elements are significant. So for example, the maximum and minimum elements are important in this problem. And you want to make sure you test the situation where those significant elements show up in unusual places. So for example, what if the maximum element is the very first element of the array? So for example, let's just make this definitely the largest element. So 9999, that's the first element. Let's make sure that my code still works. Okay, it looks like it does. And then similarly, what happens if the minimum is the last element? And I guess to be thorough, I should probably also test the converse situation. So what happens if the minimum is the first element and the maximum is the last element? Okay, that's definitely going to be the maximum now. All right, so there you go. And then I'm going to just back up some of the changes that I just made. So I think at this point I'm reasonably confident that the code that I've written works correctly, even if the minimum or maximum are at the beginning or end. I should do at least one test where I put the maximum somewhere other than where it already was, and I put the minimum somewhere other than where it already was. So there we go. The new maximum should be 99917. The new minimum should be -111. It looks like that's the case. All right, and now I should begin thinking about unconventional structures of my array. So I've got this array of size 8. I have not yet tested my code on arrays of other sizes. That's something I need to make sure that I do. And before I do that, though, I want to think about other ways the array could be structured. So for example, what happens if both the maximum and minimum element occur multiple times? So here I'm going to actually have the array be basically full of just the maximum and minimum. So there's only two distinct values in this array. I guess I still need an array of size 8, though. Okay, so there's an array of size 8, and both the maximum and minimum elements actually occur more than once, but it still looks like it works. And then finally, while we're staying with size 8, what happens if the only element in the array, or the only distinct value in the array is the maximum, and therefore also the minimum? So this array here, is that going to be 8? Yeah, it looks like 8 things. This array here has 8 elements, but the same value actually occurs 8 times, which means that the number 2023 is both the minimum and the maximum. And looks like that still works as well. That's one case that's really important to test. What happens if the minimum and maximum are the same thing? Okay, so now what I need to do is test it out on arrays of size different from 8. And the way I would approach this is I actually am reasonably confident that if the array size was 10, that it would still work. Or if it was 12 or 15 or even 6 or 4. Honestly, if you are working with arrays of some non-zero size and it works on at least a couple of different sizes, odds are it's going to work fine if you change the size further, as long as you're aware of what problem you're solving. For example, if there were something significant about the fact that the size of the array was even, then I would want to make sure to test on an odd size. So why don't we test on, for the sake of proving that point, let's test on size 7. And here I'll just back this up. So here the minimum is still going to be -8 and the maximum is still going to be 2023. All right, and it looks like that still works. I'm going to create a bug deliberately here. So what happens if I erroneously set a size to be 10. My array is not of size 10. And so attempting to do this is an error. Regardless of what comes out, this is going to be an error. This is incorrect. On an exam, you would lose marks for a mistake like this. But let's take a look. What happens if I do this? In this case, it actually appears to work. And this is a tough one. This is one of these debugging things that you may actually not know that you need to debug because the bug isn't obvious. If I exaggerate this, what if I set the size to something like 50? So clearly the array is not of size 50. And we can see here that there is something strange going on. So what's happened here is clearly this is not the minimum and this is not the maximum. What's basically happened is I've got this array of size 7. There we go, size 7. And I've decided that I'm going to claim the size is 50, which means that the loop walks through the entire array and then just keeps walking. And it begins inspecting these weird random garbage values floating around out here in the wilderness, which is bad for so many different reasons. One of the reasons is if you wander off the end of an array, bad things happen no matter what you do. But another reason is some of these weird random values can be very strange and sort of scary looking and, of course, ruin the result of your calculation. Now, what's odd about this is actually what's happened to me here is a good thing. So although I don't like seeing these massive numbers or small negative numbers showing up, I'm really grateful that this bug that existed in my program was able to manifest in a way that became visible. A minute ago where I set the size to 10 and I didn't see any adverse result, that's a bad situation. I don't want a bug to exist in my program, but if it does exist, I want to see it. So although these values are weird, I really am glad that I'm seeing them because that gives me a hint I've got a bug to fix. Okay, so of course I created the bug myself, so I can just go back and get rid of it. But you'll notice the compiler didn't help at all. And when the size was set to only 10, I didn't notice anything out of the ordinary. This is the kind of bug where you have to be vigilant when working with arrays because it's easy to create bugs that are not very easy to detect. Okay, so I'm going to go back to a size of 7. I'm just going to verify that the modification I made still works. Okay, good. Let's try an array. We'll change the size again. Let's try an array of size 5. Now I'm going to see what happens if I don't have any negative numbers. All right, so there's my array of size 5. It has no negative numbers, and I reasonably expect it's still going to work. Looks like it does. And then I will try the converse case of what if all of my values are negative? So in this case, I still expect it to work. I'm actually not really anticipating that bugs are going to occur for this reason, but for the sake of being thorough, there it is. We can see now the minimum is negative 2023, the maximum is negative 6. Okay, and then finally, I want to try it on an unusual case, which is what if the array has the smallest possible size? So here the size, I'm going to make the array of size 1 and say that the size is 1. I would expect in this case that the program works correctly, which is to say negative 6 is both the minimum and maximum. And it looks like it does. Okay, so I can be reasonably confident after all of that testing that my program is working correctly. So I think I have solved exercise 1. Why don't we just keep going in this video? Okay, so, ChatGPT calls this one exercise 2. Exercise 3, the next one I want to tackle. Write a program that reverses the elements of an array in place. So I know what the word in place means, but just as an educational demonstration, in case you're asking ChatGPT for practice questions and it uses terminology like this, let's see whether ChatGPT can explain that for me. So in exercise 3 above, you used the term in place. Can you elaborate on exercise 3 and explain what in place means? And I'm going to tell it, as I often have to do, don't show me the solution to the exercise. Certainly. So in place is, the idea behind doing an operation in place is that you have some array somewhere. So the array could be large, the array could be small. So here's my array. And there are lots of operations that are way easier when you're performing operations on arrays if you just make up a second array to do your scratch work in. So if I wanted to reverse this little array here, I may have already done this exercise in class, in fact. One really easy way of doing array reversal, or one way of making that problem easier, is make a second array just to store the reversed version and then copy that back over. So I have, in this version of the solution, I have 2 different arrays, and I'm just, I produce the reversal into a new array, and then I copy it back into the original array. The reason why I think that that's a lot easier is that it means you have a lot less juggling to do of manipulating the array you were given. You just make a second array, copy stuff into it, copy stuff back. When we use the term in place, we are referring to operations on arrays that do not require creating a second array or extra storage space for scratch work, beyond maybe a couple of variables. It looks like ChatGPT is giving a pretty complicated explanation. In place refers to a way of modifying data structures. Okay, so an array is a data structure, although this is very technical for what I've asked it, without using additional memory or creating a new copy of the data. That's a pretty succinct summary of what I just said. In the context of exercise 3, what it means is I want to reverse the array by rearranging the elements directly within the array without requiring the use of a separate array to hold the reversed elements. So this is the harder version of the array reversal problem, in my opinion. I think this is actually, I'm not looking at this too closely, but I think it's a summary of how I should solve it, so I'm going to sort of ignore that. Let's go copy exercise 3 now that we know what in place means, and we'll try and do that. Okay, so we'll go over to here, and then, there we go. Write a program that reverses the elements of an array in place. Okay, so just like before, it doesn't say that I have to do anything in particular to create this array, so I'm going to go back and dig up that array I started with in the last example. So I guess, there we go, we'll just take this array of size 7. And it will be significant when I test this next exercise that I do try it on a wide variety of sizes, in particular both odd and even sizes. But okay, this array has size 7. It doesn't contain duplicates. I should obviously test it on duplicates, but not having duplicates will be sort of helpful, I think, to help us visualize the problem. So I want to reverse the elements of the array in place. And so note on the ground rules. We can create variables, counters, elements, etc., but not a copy of the array. Okay, so that's the idea of doing the in-place reversal. If the array had size 1,000 or 1 million, I would not be allowed to make a new array of size 1,000 or 1 million. I can make as many variables as I want, but I can't make a new array to store a copy. I have to do everything by juggling the elements inside of this array. So I've got a few ways of approaching this. I tend to take the approach that it's better to use more variables and have a less confusing solution. And then if you really want to use fewer variables or try and be a hero or something, there are solutions to this. This is another one of those classic problems that people often will challenge themselves to design really compact solutions to. There are a few ways of using very few variables to solve this problem, but I'm not going to do that. I'm going to try something like this. So when solving an array problem, especially one that seems a bit complicated, I recommend the very first thing you do is draw an example on paper. So I'm using my digital paper here, but okay, so let's make up an array. There's some elements. Okay, -1, -111, and then, I don't know, there's 2023. Okay, so here's the way I think I should approach this. What I'm going to do is, my goal is to exchange 6 and 2023. So in other words, when I'm done reversing, these two elements will be swapped. And these two elements will be swapped. And these two elements will be swapped. And so the array I end up with should be the array 2023, followed by -111, followed by -1, followed by 187. Notice how this element right in the middle, this array has an odd number of elements. This element right in the middle doesn't move at all. It stays exactly where it was. It gets swapped. You can think of it getting swapped with itself. Okay, there's 17, there's 10, there's 6. Okay, so that's the way I visualize this. And I think ChatGPT's explanation a minute ago foresaw this. It said you could try swapping elements from one end of the array to the other. Okay, I know how to swap two things. And I'm beginning to get an idea of a technique that I might use to do this by modifying the array. What I could do is, I guess I have to do a little bit of erasing here to just clear up my diagram. So what I could do is, I could keep track of, if I'm going to do a bunch of swaps, I could sort of start at the beginning and work my way inward. I guess I'm starting at both ends at once. I start by swapping the two things at the ends, and then I swap the two things that are one element in from the end. And these little arrows I'm drawing sort of give me a hint that what I might want to use is an index variable. So I start with an index that refers to the beginning of the array and an index that refers to the end of the array. And then I have one of them go forwards, so to the right, and one of them go backwards, so to the left. I'm not sure what the best thing to call those indices is. I guess I might just call them, actually, why don't we call it this? We'll call our two index variables left and right, or index left and index right. So I'll call this little index variable here IDXL, and this variable here IDXR. So IDXL is on the left-hand side of the array, IDXR is on the right-hand side, and the IDXL moves inwards, so that is to say it moves to the right, and IDXR moves inwards as well, which means it moves to the left. And then I keep swapping things. So at each step, I grab the thing that, well, let's start at the beginning again. At each step, IDXL points here, IDXR points there. I grab the thing at each position and I swap them. So 2023 ends up there, and the 6 ends up here. And then I move my indices inwards a little bit, and then I do the same operation again. And I actually should work all the way through this, even though the diagram is going to become a complete mess. Okay, so there's -111. I move this one inwards a bit, and I move this one inwards a bit, and then I swap them. So this one becomes -1, and this one becomes 17, and then I move them inwards a bit, and I notice that when I've moved them both inwards, they're now exactly the same. They're now at the same location. And that sounds to me like a good place to stop. So I'm going to try that. And I'm going to notice a little bug that shows up later when I do it that way. All right, so I'm going to make two index variables. Let's see. So I'll do int IDXL equals 0, so that starts at the beginning, and IDXR equals the size of the array minus 1, which is the last valid index. Okay, so now I'm going to loop over my array, and I'll just sketch my diagram back out again. So I'm going to loop over my array and have the indices move closer together until, at the moment, I guess what I'm going to do is say until the indices end up being at the same position. So when L and R both happen to match up, when they're both indexing to the same position, that is when I will stop. So I'll say while IDXL is not equal to IDXR, then I keep going. Okay, so what does it mean? Well, to keep going, what I'm doing at each step is I'm grabbing the thing that IDXL refers to, and I'm grabbing the thing that IDXR refers to, and I'm swapping them. We saw a few videos ago that if I want to do a swap, the most convenient way, I guess, mentally for me at least, is to take one element, put it in a temporary location. So I'll go grab the thing at position IDXL, put it in a temporary variable. I will then store into the position at IDXL, whatever is currently in IDXR. And then I will take that temporary thing I saved up and I'll stick it into IDXR. Okay, there we go. And then I have to make progress in my loop, so I move IDXL forwards, so that's plus plus, and I move IDXR backwards, that's minus minus. And I visualize that by saying, okay, IDXL moves ahead by 1, IDXR moves backwards by 1. And if I weren't sketching this out on the side, I probably would get lost, and I probably would make a small mistake in this. I could probably generate this algorithm mostly in my head, but if I don't draw it out on the side, I could make a typo or something that would be very hard to diagnose. Okay, so we'll try that out. I guess I have to add some code to print the array. I'm going to write a loop that prints the array at the beginning and at the end. So I is equal to 0, I is less than a size, I plus plus. Oh, I hit page up by accident. So I'll just print out the value of a at that location, and then when I'm done printing, I will, there we go. I'll just print out a new line. Okay, so I do that at the beginning, I do that at the end. And I should expect, therefore, that when my program runs, I observe that one line is the original array and the next line is the reversal of that array. So there we go, practice arrays 2. Practice arrays 2. Okay, so 6, 10, 17, negative 1, 187, 2023, negative 8. And down on the line below, it is indeed reversed. It doesn't line up perfectly just because some numbers are larger than others. Actually, I could make it line up a little bit better. So I'd sort of like it if the elements were neatly arranged into columns. The problem is, for example, this number 6 is 1 digit, whereas this negative 8 takes up two characters. What I can do is use I can modify my %d specifier. Let's do %5d. So remember that if I use %5d, it's telling printf, I want to use 5 characters to represent each number. And if the number is less than 5 digits long, just pad it out with spaces. And that gives us this nice aligned appearance. Okay, so 6, 10, 17, negative 1, 187, 2023, negative 8, negative 8, 2023, 187, negative 1, 17, 10, 6. And I'm observing now that in the earlier example I drew out over here, I used the wrong set of numbers, but I think the effect is the same. Okay, so it looks like it is doing the reversal. And so, of course, my program isn't yet working because I haven't done enough testing. Let's do some more testing. In this case, I'm not that worried about changing the element values, to be honest, because I sort of understand that nothing that the code is doing is actually manipulating the elements. It's not adding numbers to the elements. It's not even really moving them around except by swapping them with each other. So I'm not going to do that much testing that involve changing element values. So here I've negated the number 17. I could see what happens if I have duplicates, though. So let's see what happens if I have 2 negative 17s. I'm not expecting too much to happen here, but just in case, it's good to test. Okay, so there are the 2 17s together, and there they are as well. So, okay, I'm not going to worry any further about changing element values. In the previous exercise, I did worry about that because computing minimum and maximum involve comparing elements to each other. So I'm comparing the element to the current minimum or the current maximum. So the magnitudes or the values of those elements could contribute to this. I don't think that's happening here. The only comparisons I'm doing are between indices. But one thing I absolutely have to test is changing the size of my array. So let's just, as maybe a red herring, let's see what happens if I change to an array of size 5. So I used size 7 before, and now I'm using size 5. You'll observe that both of those are odd numbers, and that should be a little bit alarming. I need to test on an even number of elements. It's looking like the swaps all worked. It's looking like I'm generating the reversal correctly. Let's see what happens if I use an array of size 1. I should be allowed to do that. So I should be allowed to reverse an array of size 1. And really, the code should do nothing, but it certainly shouldn't crash or generate any other form of error. And it looks like it's working. So, I mean, the reversal of an array of size 1 is just that array itself. Okay, so now what about testing on an even number of values? So let's add, I guess earlier I was putting number 23 here. Okay, so A is now an array of size 8, and I will run the code again. I'm going to clear my diagram from before, and we'll see what happens. Ooh, okay, so something really nasty happened. And this is a tough one. I don't know if I have general advice of a trick that's guaranteed to actually debug this quickly. I do know what's causing the problem. Maybe you could tell I was sort of setting up this example. My suggestion is if you notice a behavior like this, so you had code that was basically working for that array of size 7. So up here it was working. That's evidence that your logic is almost entirely correct, which means this probably won't be a case where you have to throw the code away and start over. So because of that, because this is a what, 20 lines of code or something, of the meaningful part of it's maybe 10 or 15 lines, because there's a reasonably good chance you're not going to have to throw everything away and start over again, it is worth investing a little bit in debugging this. So that is to say, don't necessarily panic, and don't worry about not having a trick that lets you spot the error instantly. Instead, try tracing the code. If you trace the code by hand, so maybe if we chose an array of size, maybe we'll do an array of size 4 for that purpose. I'm not going to do the full trace in this video, but because I do know what the bug is. But if you notice this weird unexpected error out of nowhere, especially this one, which gives you very little evidence of what's causing it, you could just trace it by hand. So you could try tracing it by hand with an array of size, I'll set that size to 4, and see what happens. I suspect that in the case of this particular bug, you would catch it. Yes, it would take 5 or 10 minutes, but you would catch it. A trace, although tedious, does usually yield pretty good results when there's a bug that isn't obvious. So that's one thing you could do. Another thing you could do, as sort of a halfway solution, is because you know that the code is generally pretty functional, you could just add extra print statements for debugging purposes. You could print out what you know. So for example, I could say, hey, how long is this loop taking? Where is it having trouble? So we know that this segmentation fault can happen for a variety of reasons. Let's now take a look at, I'm going to add an extra print statement to print out the values of all of my variables at each step of the loop, because I suspect the problem is coming from inside the loop. So IDXR is this, A at IDXL is this, and A at IDXR is this. Okay, so we'll try running that. I haven't fixed the bug. I should expect the program will still crash. I will still get a segmentation fault. But maybe, in the meantime, I generate some data that helps me find the problem. So I'm going to run this. All right, so let's take a look. It prints out the initial array, 6, 10, 17, negative 1. Now, the print statement I'm doing here is after the swap. So I should expect that after for example, I start out with IDX, actually, I'm going to move this print statement. So notice how the first line, it says IDXL is 1 and IDXR is 2. But that doesn't make any sense. Don't I start IDXL off equaling 0? Well, I do. The issue is I've put my print statement after I've modified IDXL. So I think what I'm going to do is actually move my print statement to the beginning of the loop, because I suspect that that makes it easier for me to understand. And many of you have already had the experience of coming to my office hours and I suggest this as a debugging technique and you probably hate it. And I don't blame you, because it's a wall of data and it's sort of hard to filter through it. But it might be faster than tracing, and everybody seems to hate having to trace their own code, so it's worth a try. And the more data you dump out, the more likely you can sift through it and identify the pattern that shows you what's wrong. Okay, so here IDXL is 0 at the very first step. That makes sense. The array has size 4, so IDXR is 3. That makes sense. The index, the element at index IDXL is 6. Okay, that adds up to me. The element at index R is -1. Okay, so then I swap them, presumably. If I was worried that the swap wasn't working, I could always print out the elements again on line 30 to verify that they swapped successfully. But I think it is working. The next step, IDXL is 1, IDXR is 2. The elements are 10 and -17. That looks good. Okay, and then this happens at the next step, but wait, I'm already done. I've already swapped 6 and -1, 10 and -17, but the loop keeps going. Okay, it looks like I found my bug. Now the question is, what do I do to fix it? Okay, so at the next step, IDXL is 2 and IDXR is 1, and that doesn't add up. So that clearly doesn't match the algorithm I was trying to create when I wrote this code earlier. The idea that I had earlier was that IDXL would point to something on the left-hand side of the array, and IDXR would point to something on the right-hand side of the array, and they would get closer together until they were equal to each other, and then I would stop. What seems to have happened here is that IDXR and IDXL have crossed each other. So now IDXR is going to continue going backwards forever, and IDXL is going to keep going forwards forever. Notice that now IDXL is 3, then 4, then 5, then 6, then 7, and IDXR gets into negatives. And you can see that eventually I walk off the end of the array in both directions. IDXL is now way off the end, IDXR is way off the end, and I even begin seeing weird garbage values. And then the program crashes. Probably what's happening when the program crashes is I'm walking so far outside of civilization that I end up being somewhere I'm not allowed. And then the operating system jumps in and stops me. Now, I don't care that that's what's happened. What I care about is I noticed the bug in my code. So now how do I fix it? Well, I think I sort of see what might be the problem. And I'm using two pieces of evidence. The one was this worked perfectly when there were an odd number of array elements. So when my array had an odd size, so for example, when it had size 5, then there was a situation where IDXR and IDXL were sitting on exactly the same element. They were equal to each other. But in an array of even size, there isn't going to be an element exactly in the middle. So when IDXR points here and IDXL points here, if I then take one more step, then they end up crossed over. IDXR is less than IDXL, and that's my problem. My loop condition is only, well, they're not equal. But they're never going to be equal if the size of the array is even. So what do I do? Well, I think I should just go back to thinking about my original assumptions about IDXL and IDXR. The idea is that IDXL is something on the left-hand side of the array, and IDXR is something on the right-hand side of the array. So I expect that IDXL is always less than IDXR. So maybe I just need to change my loop condition. I change it to while IDXL is less than IDXR. And if they're ever equal, then this condition will fail. And if IDXR ever ends up being less than IDXL, the condition will also fail. Okay, so we'll try that out. We're still working with our array of size 4. I'm not even going to get rid of my print statement because I'm not yet sure that this fix is going to work. But it looks like it did. Okay, so I'm going to comment this out and then run it again to make sure it looks good. Okay, that looks good. And then I'm also going to try out my array of size. Let's do 111, 2023, 823. I'm going to go back and have my array of size 8 again. Okay, it looks like that reversed correctly. Okay, so it looks like I have fixed the bug that I had that I noticed earlier, right? No, actually not quite. So I changed my code. I've now tested on a couple of different arrays of even size. I could even go one further and try it on an array of size 2. So I'm testing on arrays of even size, and they are now working. Previously, they were broken. So, of course, that's certainly a good sign. I fixed the bug, but I can't assume my code is correct because I changed something. Since the last time I tested, I've changed something. And I earlier did a bunch of tests on arrays of odd size. I don't know for sure that what I did didn't break the behavior of my code on an array of an odd size. So I need to test that again. The situation where that happens, that's called regression. So in the case where you fix a bug and then a bunch of stuff works, but other stuff that was working becomes broken is called regression. And I want to prevent a regression from occurring. I want to make sure that I don't fix one bug but inadvertently create another. So I need to go back and do a bit more testing of arrays with odd size. Okay, it looks like that's now working. So I've tried an array of size 7. We'll just do one more. So we'll do an array of size 5. All right, and it looks like that reversed. Okay, so after all that testing, I can now be confident that my code is correct. So I think we're on a roll here. Why don't we just move right on to the next exercise? So this was exercise 3 in ChatGPT's terms because I ignored its original exercise 1, and then I asked it for a clarification. I wanted a better exercise, a replacement for exercise 1. So I've got this. I'm going to ignore that second paragraph because I think that's a hint on how to solve it, and I don't know if I want that kind of a hint. And I'll go over to my exercise here. I'll just paste this in. Okay, write a program that takes an array of integers and a target integer as input. The program should count and display the number of occurrences of the target integer in the array. Now, frankly, this is probably an easier exercise than the last one. I'm almost tempted to try and think of maybe good ways of making it harder. I'm going to ask ChatGPT for a clarification on something. This time it says it takes these as input. So maybe I should ask ChatGPT what it means. In your updated exercise 1, when you say as input, do you mean user input? Also, don't show me a solution, please. Okay, so it turns out that when it says as input, apparently, so one thing you'll notice with ChatGPT, and you might have seen this in previous videos, is that ChatGPT really likes agreeing with you. So if you ask leading questions, it often will just say yes. So and this goes in a lot of weird directions. So in other words, if you say, here's my answer to the exercise, is it correct? I think it's right. Often it'll say yes. Like it doesn't necessarily apply very much critical thinking to what you give it, because it's not designed for that. Okay, so it's claiming that yes, when I mentioned as input, the program should be taking input from the user. In this case, the program should prompt the user to enter an array of integers and a target integer, and then it should perform the required calculations based on this input. Now, this makes the exercise, I think, a lot more exciting. But I already have a question, which is, wait, how does the user know how big the array is supposed to be? Like, you ask the user to enter an array of integers, you need to make an array to store the values into. So how do you know how big to make the array? When I ask the user for input, to input an array, how do I know how big the array is supposed to be? Now, there are a couple of ways it can answer this. We're going to have to swerve in a specific direction here, because there's one solution it might suggest that's too advanced for us. When asking, okay, it's going to do this. Okay, so it's going to suggest, it looks like it's going to suggest a few different options. So one option is just to ask the user to enter the size of the array. That's the one I was hoping it would suggest. It's given me a few options. I'm just going to choose this one. And so it's giving a hint. I don't want to look at that because I actually want to do it myself. You could use a sentinel value. So you could ask the user to input array elements until they enter the number 0 or something. And the problem with that is, what if the user wants to add the element 0 or whatever sentinel value you choose as an element of the array? Although this technique is very powerful in some contexts like strings, which we haven't talked about yet. Looks like those are the only two options. Okay, so fine. I actually like the first option a lot, so we're going to use that. I'm not going to, I did see that code, but I'm going to try and write my own code from scratch. Okay, so what I'm going to do is I'm going to just add the elaboration there. The program will first prompt the user for an array size, then create an array and read the array elements from the user, followed by the target integer. That's what it's calling it, the target integer. So the idea behind this exercise appears to be, if the user enters an array like this one here, and they give as their target value the number 6, the program is supposed to go through the array and count how many times it sees the number 6 in the array, and then print out that it saw the number 6 2 times. It's going to count the number of occurrences of that target value. Okay, but fortunately there's a bunch of other infrastructure that I have to deal with first. So first I'm going to prompt the user for an array size. Okay, so I'm going to say enter an array size. And already this is sort of meaning I'm already seeing that probably when I do my testing, I won't need to recompile very many times. I'll just try typing in different sizes and seeing what happens. Okay, so I'm going to call this size, say equals 0, and then I'm going to use scanf to get the user to tell me the size of the array that they want. So I'm going to ask scanf to read me one integer, and I'm going to store it in my variable size. Notice the ampersand, because with scanf we need to provide pointers. If that's not equal to 1, so I ask scanf to read me one item, and its return value will be how many items it read. If it doesn't return the number 1, that means it was unsuccessful in reading that integer, that array size, and so I'm just going to tell the user that that's their problem. So you didn't enter an array size, goodbye. Okay, and then I will exit the program. So returning from main exits the program. Now, if they did enter an array size, I still have a couple of issues, which is if the array size they entered makes no sense, so if they gave an array size that was less than or equal to 0, then I've also got a problem. So we'll just You call that an array size? Goodbye. Okay, so if the sizes doesn't make any sense, then I'll also quit. I don't want to worry about that. That's sort of the user's problem. Why are they messing around? Programming is a serious business. Now I'll make an array. So as of line 28, I can reasonably assume that my size makes sense, although might want to make sure the size isn't too huge, but I don't know how to do that. So who knows how big the array is. I guess if the user wants to enter 5 million things, I guess they should be allowed to try. So on line 29, I make an array of the size that was given. And so in this case, I actually don't know when I compile my program how big the array is going to be, but I'm allowed to make an array whose size isn't known at compile time, as long as the size is known by the time I run line 29, the statement here. Okay, so now I'm going to ask the user to enter that number of values. Enter your okay, so I'm going to remind the user how many values that they wanted to enter, so I'll tell it the size. And now I'm going to run a loop that reads all of those values. So the way I'm going to do this is I'm going to use scanf to read one value over and over again this number of times using a for loop. So I'm going to say for int I equals 0, I is less than the size of the array, I plus plus, our standard array loop. And then at each step, I'm going to say, okay, if I'm going to ask scanf to get me one integer from the user, so there's %d, I'm going to read it into index I of my array. So I is the index I'm working with. I'm going to use this notation, which is I'm talking about element I of the array, and I want a pointer to it so that I can get scanf to read the value into that array element. If that's not equal to 1, I ask scanf to read me one value here. If that's not equal to 1, then we've got a problem. So again, this is a serious business. This is serious. You didn't enter value this one. Goodbye. We don't have patience for users that can't be serious. Okay, so I will tell it which index I'm having a problem with. You didn't enter the value for index whatever. Okay, and then I'll exit the program. Again, no patience. If the user can't follow the rules, that's their problem, not mine. Okay, so then at the end of this loop, I should expect that I've filled up the array with values, and I might want to be a little bit paranoid about this, so I'm going to actually print out all of the values over again. One of the reasons I'm doing this is I'm beginning to notice I just scrolled down. You notice that I just scrolled down a bit. If I'm scrolling down in my code before I've tested it, that's a sign that maybe I need to start testing. Even if the code isn't done yet, I actually haven't done the important part of the exercise. I need to start compiling and testing my code. So I'm going to add one more thing because by now I'm confident enough that I know how to print out array elements. I'm going to try printing out the elements of the array. The elements are... and then I'm going to print them out. And now I'm going to compile and run my code. And, to be honest, I hope that like 5 minutes ago you were yelling at the screen saying, you need to compile right now. You're writing too much code. If this doesn't work, if this code doesn't compile or there's a bug in it, I might have to delete all of it. There's too much of it here for me to methodically debug it in some cases. So I'm taking quite a risk by what I've just done. So this is a case where do what I say, not what I do, I guess. I compiled, and with a bit of a sigh of relief, I can say it did compile. Okay, that's a good sign. Now we're going to try running it. Okay, practice arrays 3. Enter an array size. Okay, we'll start with an array size of 3. Enter your 3 array values, 6, 10, 17. The elements are 6, 10, 17. Okay, that's a good sign. Before I go further, let's make sure that this early part of the code is 100% good. So let's actually fully test that it's reading the array correctly. I'm going to enter an array size of 5. So we'll do 6, 10, 17, 187, 111. Looks like that's fine. Let's see what happens if I don't enter a size, if I just enter junk. Okay, then it gets upset, and I don't blame it because I should be serious. Enter an array size. Let's try an array size of 3. Here I'm going to enter 6, then 10, then some garbage. And it's going to say, sorry, you did not enter a value for index 2. Goodbye, because I only entered 2 things and not 3 things. Now, one note, the way this detection is set up, if I do give it all of the elements it wants, so I say, okay, here's 6, 10, 17, 187, 111, and then some garbage, it doesn't mind. As long as it gets the 5 elements it was looking for, it doesn't care that I then get distracted and begin doing random stuff. So I guess I'm somewhat confident. Let's do one more. I want to make sure it works with arrays of size. Oh, actually, what happens if I do an array of size 0? Nope, not going to work. What if the array size is like -5? Still not going to work. What if I do an array of size 1? Okay, well, that should work, and it does. Okay, so it looks like that this part of the code works correctly. I'm not done the exercise. I'm actually barely started the exercise. I've read the array from the user. Now I have to read the target value. I'm just going to call it the target value, even though that is a bit of a weird, maybe the search value is a better term. So I'm now going to say enter the target value. Okay, and I'll call this target. And then I will use scanf again. I'm actually going to copy some of the code I already wrote for this because I've already got the error message there. So I'm going to read my target value. I'll read into target. You didn't enter a target value. I guess I could have typed this from scratch. Okay, so I use scanf again to read from the user their target value, and if they didn't enter it, then I just exit the program. Okay, so I'm going to say the target, whoops, I need to spell target correctly. The target value is this. All right. I'm going to try running that immediately because I need to make sure I test often. Enter an array size, we'll do 3. There's my array elements, 1, 2, 3. Enter the target value, it's 6. The target value is 6. Okay, we'll do one more. Here, array size of 1, the value is just 1. Target value 10, good. I should do a test of the error case. The error case is what if I enter some junk? Then it complains. Okay, that looks good. I'm pretty sure that the target value is being read correctly. Okay, so what was the exercise again? I need to now count and display the number of occurrences of my target value inside the array. Okay, so I'm going to need a count for that. So I'll make a count, and now I'm going to iterate over my array, and I'm just going to ask at each step, is the element at this index equal to the target value? Okay, and so this part here is an exercise we've actually done already. Like there are videos of this exercise already out there. So int I equals 0, I is less than the size, I plus plus. Okay, I got to get my spacing more consistent. In this code, I'm not using these spaces. Okay, and so at each step, I'm going to ask the question with an if statement. If a sub I is equal to the target value, well, then I've just found another occurrence of what I'm looking for, so count plus plus. And then way down at the bottom, finally at the end of my program, there were this number of occurrences of the element, and I'll just print out the element in the array. And so I print out the count, I print out the target value once again, just to be clear. I'm going to clear this. We'll try compiling. Everything looks good. So we'll do practice arrays 3. Enter an array size. Okay, we'll start with an array size of, let's do 3, 6, 10, 17. I'm going to start with a target value of 17. And it found 1 occurrences. That's a little bit, you know, since we've polished this code so much already, let's if the count equals 1, then I shouldn't pluralize the word occurrences, should I? So we'll just, there was, just make sure we have correct English. There was 1 occurrence of the element in the array, and then otherwise we'll pluralize it. It's the small things, you know, this professional polish is very important. It makes a good impression on your user, even though otherwise I'm worried the user's not going to be serious. So we'll compile and run that again. Okay, so array size is 3. My 3 array values are now 6, 17, and 10. My target value is again 17. There was 1 occurrence of that element. Okay, so now what happens, let's do an array size of 5. Let's see what happens if I've got multiple occurrences of the target value. Okay, my target value will be 10. There were 3 occurrences of that. Okay, what happens if my array size is 1 and the element is 9 and I search for a 9? There was 1 occurrence. What happens if I don't find the thing I'm looking for? So I use my array size is now 3, 6, 10, 17. I'm going to look for the value 187. There were 0 occurrences of that. This is all looking good. Okay, what other tests have I not done? I've tried arrays of size 1. I've tried ensuring that the value, that it works if the value is there multiple times or if it's there 0 times. I should try, see what happens if I have an array of maybe different sizes. So let's do size 5. I should also make sure I test on negative numbers. So we'll do -6, 10, -6, -6, -6, and my target value is -6. There were 4 occurrences. So it does appear to also work on negative numbers. I guess I should also do one perfunctory test on zeros. So 0, 111, 116, and 0. My target value is 0. There were 2 occurrences. You'll also notice that in the tests that I did, I tried to make sure that there were a few cases where the target value showed up as the first or last element, as well as in the middle somewhere. So with arrays, it's very common for there to be special cases involving the first element or the last element, or in cases where the array has size 1, the only element. I have now tested all of those. I think I can now be reasonably confident, even though this is quite a bit of code, I can be reasonably confident that what I have is pretty much correct and implements the exercise. And I'm really happy that ChatGPT was able to elaborate the exercise in a way that made it, not sort of boring, because the actual core of it, the actual task we were trying to complete, was pretty simple. And it was sort of, I didn't want to follow exercise 2 as something that was too simple.